Welcome back to the online learning classes. Before we start today's topic, let us recall what we have studied in previous lecture. We studied about motion, distance, and displacement. Force, the interaction that brings about the acceleration, is called force. In this, you can see that the velocity of the moving body decreases. This is due to force of friction. Let us do one experiment. The carom coin pushed by a striker will move forward some distance and then come to a stop. If the coin is pushed after applying talcum powder to the carom board, it will keep moving for a longer time and then come to a stop. The velocity of the coin decreases due to force of friction and the coin stops. If the friction between the carom board and the coin is reduced, the coin keeps moving for a longer time. It would mean that if no force of friction is acting on a moving body, it will keep on moving with a constant velocity. Now we will see Sir Isaac Newton. Now we will see Newton's first law of motion. If no force is acting on a body, its velocity will not change. The body will not show acceleration. If a body is stationary, it will remain stationary. If it is in motion, it will continue moving with the same velocity and in the same direction. If the force acting on the object is zero, then its acceleration is also zero. You have learned what is meant by force. You have seen that a body is accelerated due to force. Suppose you place the 1 kilogram standard weight on a surface with no friction and pulled it with an acceleration of 1 mass per square. The force applied is called 1 Newton. Try this. Place a weight of 1 kg on a smooth wooden table. Spread some talcum powder evenly on the table. Now pull the 1 kg weight with an acceleration of 1 meter per second square. Again pull it with an acceleration of 2 meter per second square. It means that now you have pulled a force of 2 Newton. You will have to take many trials for this experiment. Force is measured by the acceleration that it produces. We have learned about the relationship between the displacement of a body resulting from the force applied to it and the work done. We have also learned about the work energy relationship and that the ability to do work is called energy. The next one is force, displacement, and work. In this figure, along a string attached a wooden block on a table is passed over a pulley and tied to a weight. On applying a sufficient weight, the block will be seen to move. If the block moves forward, we can say that it has been displaced. Due to the displacement, we say that the force has done some work. We can measure this work. We know that work done depends on the force and the displacement. Now we will see the formula expresses this relationship. Work done by force applied to the body, displacement of the body that takes place in the direction of force. work is W. F means force. S means displacement. In the SI system, the unit of work is joule, J, while the unit of force is Newton, N, and the unit of displacement is meter, M. In the CGS system, the unit of work is erg. If a force of 1 Newton parallel to the surface of the table is applied to a wooden block on the table and the block is displayed by 1 meter, then it can be said that the force has done 1 joule of work. In this example, the displacement is in the direction of the force.